Welcome back to Wages and Employment at Wilfrid Laurier University. Today, we're going to look at how we model labor demand in the long run. For reference, you should pair this video with readings in Chapter 5 of your textbook. We think of the firm's problem in two stages. In a first stage, the firm thinks about how much labor and capital to employ for a given level of output Q. And you can imagine them repeating this exercise for every possible level of output imaginable. They take their input prices, which is the rental rate on capital and the wage rate for labor. They take these as given and determine what is optimal in terms of the inputs they use in production. In a second stage, then, they decide what the profit maximizing amount of output to produce is. For a competitive firm, this is a matter of finding that level of output whereby the price that they can charge for a good is equal to the marginal cost of producing it. To map this into a diagram, we can start with isocost lines. Each line will describe the combination of inputs K and N that cost the same amount to employ. Consider a total cost level C1. With prices given at R0 and W0, the isocost line presented here shows all the combinations of K and N that could be used with the same total cost C1 in mind. Notice the slope of this isocost line is the ratio of input prices. When wages are high relative to the rental rate, this line will be steeper. When wages are relatively low, the line is flatter. So then consider a higher total cost level, C2, but with the same relative prices. This would give us a new higher isocost line, but with the same slope. You can also consider a lower total cost level, C0, but again, with the same relative prices, the slope of this line is the same as before. So then we want to think about what happens when the wages rise from W0 to W1. We need to recreate our cost lines. For a given amount of labor and capital, say K0 and N0, a higher wage rate means a total higher cost, which we'll call C1 and is represented by a new isocost line with a steeper slope. Notice that our intercepts for this line have changed, as well as the slope of the isocost line. The isocost lines will help us describe the cost minimization part of the firm's problem, but we also need to account for the level of output the firm wishes to produce. For this, we introduce the isoquant, which shows the combinations of capital, K, and labor, N, that can be used to produce a given level of output, Q0. If we wish to consider a higher level of output, say Q1, we would have to consider an isoquant that represents the use of more inputs. The important thing to know about an isoquant is that its slope represents the marginal technical rate of substitution, describing that extent to which we can trade off using one input for another while holding output constant. The profit maximizing firm is then going to bring this together. It goes through this process of mapping out its isocost lines for every possible cost level. It also maps out the various combinations of inputs required for various levels of output. We effectively have a full mapping of several isoquants and isocost lines. It determines it wants to produce a level of output, say Q1 here, and we'll see them choose the cheapest capital labor combination possible to produce this in order to maximize profits. That happens where the isoquant for a profit maximizing level of output is tangent to the isocost line. At this profit maximizing point, we'll find the marginal rate of technical substitution that is exactly equal to the ratio of relative prices. In our next video, we will be continuing with labor demand. See you then.